morning, everyone. Thank you so much for joining. Welcome to today's webinar covering corrugated steel bridge and tunnel solutions. Our two presenters today are Ron Verhico, a professional engineer with our Prairies team, and Lauren Mielty, our technical sales representative in British Columbia for Armtec-Drainage Solutions Business Unit, whom I'll introduce more shortly. My name is Janine Yetke, Director of Marketing for Armtec. My group runs Armtec's Drainage Solutions webinar program, and I'll be your host for today's event. We also have James Carter on the line, who is our technical moderator and who will be running questions and answers at the end of the session. First, I'll quickly go over some housekeeping items. During the presentation, if you have any questions, please enter your question into the question log. If you're sitting in a boardroom or with a group of people, please designate someone to collect and input the questions from the group into the question log. We encourage everyone to join in this discussion today. If we're not able to get to your question due to time constraints, please rest assured we will respond through email after the webinar. As a reminder, attending the session will qualify you for a 1-hour technical and formal CPD credit. For those who have registered directly, we'll send out the certificate to the email provided upon login. For those who are attending as a group, please compile your list of attendees and send the attendance list with the required details to webinars@armtec.com. I'd like to start off with a brief introduction to Armtec. We're one of Canada's oldest and largest infrastructure companies, supplying solutions ranging from steel and HDPE-based bridge and culvert materials to precast building systems. With locations across the country, we are well positioned to serve your needs wherever you are, both nationally and internationally. As you can see, Armtec offers products in a wide range of categories, including precast products such as building systems, parking structures, and sound wall systems. On the drainage side of the business, we offer pipe and culverts, engineered steel bridge solutions, stormwater management systems, and much more. We serve numerous sectors, from the municipal and transportation sectors to forestry and mining and energy. More about how we service these sectors can be viewed on our newly revamped website or through discussion with one of our experienced sales representatives. With our centralized engineering department and regional engineers, Armtec has the exceptional capability to fully support design and challenging engineered project requirements. Our company also has the expertise to take your project through all phases of the design and construction process with the design build delivery method. As you can see with this map, we have manufacturing and sales locations suited to meet your local needs across Canada. We look forward to your questions and learning how we can support you. Ron and Lauren have a wide range of experience with corrugated steel solutions that meet a variety of project challenges, which they will present today. Ron is a region engineer serving the Prairie region with over 25 years in the industry. He has extensive experience in providing budget-friendly solutions for complex projects on tight schedules. His expertise extends the full range of Armtec drainage and engineered solutions, and he is relied on to provide advice and recommendations for challenging job sites across the Western region. Lauren is a technical sales representative with Armtec, located in British Columbia, with over 30 years of experience in a range of industries, including road construction and oil and gas. He consults regularly with engineering consultants and municipalities to identify the best solutions for their needs and supports Armtec's entire portfolio of drainage solutions, including bridge plate, multi-plate, and MSE retaining walls. Both of them look forward to plenty of questions and answers after this presentation. And with that, I'll now hand off this presentation to Ron Verhico. Welcome, Ron.
Thanks, Janine. I think by now everyone can see my screen. Good afternoon, good morning, and thanks to all for joining us today. Here's the agenda for today's webinar. My colleague Lauren and I will be focusing the majority of our time on item number 3 today, presenting case study projects. And it's through these projects that we will showcase challenges faced by bridge engineers and consultants right across Canada in which corrugated steel plate was able to deliver a viable, economical, and sustainable solution. After this presentation, we are hopeful that you will consider corrugated steel plate for your bridge replacements. So let's get started. Here are the two products we'll be discussing today, and this shows a good comparison. Multi-plate is the product on top of this slide and is referred to as a shallow corrugation, or SPCSP, structural plate corrugated steel pipe. Bridge plate is referred to as deep corrugations, or DCSP, deep corrugated structural plate. The development of the deep bridge plate corrugation translates to 10 times the plate stiffness of multi-plate and more than 4 times the moment resistance. So let's explore these two products a little bit further. Multi-plate shallow corrugation is a more mature and proven product. Invented by Armtec in the early 1930s, multi-plate is a very versatile and customizable product for most applications. Various shapes are available and many standard sizes have been developed for multi-plate. Armtec's website provides these sizes, or you can contact your local Armtec representative for these. Although available in diameters and spans from 1.5 to 7 meters, multi-plate structures are really very competitive product options in the spans from about 3 meters to about 5.5 meters. The design and installation of shallow corrugations are in accordance with the Canadian Bridge Code. Bridge plate is available in 3 shapes: arches, box, and round. And there is a very large selection of standard sizes to meet most applications. The enhanced section properties of bridge plate allow much larger spans without the need for special features, which would otherwise be needed in the sizes indicated on the slide here. Arches are available in 3 shapes and are the most common: single radius, low profile, and high profile. There's also a wide array of box culvert shapes available as well. And with its low rise to span ratio, it makes these ideal shapes for low profile and low cover applications. As with multi-plate, the design of deep corrugations follows the Canadian Code Section 7 for buried structures. Another new development and recent development for corrugated steel plate structures is the availability of a very highly durable product, polymer coating technology. STRATA-CAT is a dual coating system consisting of a base zinc layer and a top coat polymer finish. STRATA-CAT or polymer coatings are ideal for aggressive water and soil environments, which are encountered quite frequently in the Canadian environment, and also for providing long service life to meet the defined minimum requirements of the crossing. The term CAT in STRATA-CAT is an acronym for corrosion arresting technology. The coating process is done in a factory environment and is very stringently controlled to assure outstanding consistent adherence of the coating. This includes sandblasting and thorough cleaning prior to separate applications of the zinc and polymer layers. On the left, the plates here have received the coating electromagnetically and are entering the high temperature baking oven. On the right, plates are emerging from the coating process here and getting ready for shipment. In addition to perfecting the coating process, several test sites with the coating have been studied. This is an example of one here. This crossing has a very aggressive surface flow water located in the Sudbury, Ontario area. The pH of the water here typically is quite low and very acidic, and the water is soft, and this type of environment is not kind to galvanized coatings, as you can see on the right. The photo here shows the zinc has been consumed over a very short period of time, exposing the bare steel. And if I recall, the photo here was taken after about 6 years of in-service. On the left, several of the plates have been coated at this test site with STRATA-CAT and were inspected and were in pretty much the same condition as the day they were installed. So here are a couple examples of the creative use of this coating. Segmental plate structures like multi-plate and bridge plate lends themselves very well to coating the inverts, which is the area typically subjected to water corrosion, abrasion, and also increased wear. The performance guideline that you see up here has been published to assist designers and stakeholders in selecting the appropriate structure type, the optimum coating and plate thickness, and of course all this is to enable these structures to meet the required design service life for the crossing. For STRATA-CAT, in relatively neutral environments, 100-year estimated material service lives can be achieved. This guideline and accompanying white paper is the culmination of many years of research and development. And access to these documents is available through the Corrugated Steel Pipe Institute at cspi.ca. I also wanted to mention that the CSA standard G40114 governs all the materials, fabrication, and inspection, repair of corrugated steel pipe products manufactured by Armtec, including the STRATA-CAT coating that I'm presenting here. For your copy of this standard, please visit the CSA Publications website. So let's explore here now some case study installations. The reconstruction of Muskoka Road 50 in Ontario necessitated the replacement of a failing box culvert. Armtec designed and supplied the deep corrugated plates to the general contractor, which in this case was a 12-meter span bridge plate box culvert shape. The shape and size was selected to suit the new grade lines of the road and to meet the consultant's hydraulic sizing criteria. A few more photos here. This project is located near Bracebridge, Ontario, and it's well known that the surface waters in this region are low in pH and quite acidic, and also lack the buffering ability associated with normal surface water. To meet the design service life criteria, the side arc plates were supplied with the STRATA-CAT polymer coating to above the anticipated high water level mark. The rest of the plates were supplied with a hot dip galvanized coating. As with most all segmental plate projects, in the bottom photo of this slide, pre-assembly of full rings results in significant time savings during the construction. And Armtec frequently works with contractors to assist them in reducing the amount of time during the construction of these projects. Foundation design for open bottom structures is customarily carried out by the consultant of record, and a geotechnical investigation by local consultants is required to determine bearing capacity and suitability of various foundations. T-shaped foundations shown here in either precast or cast in place have been successfully utilized and provide two potential advantages. The bottom of the footings are founded well below the stream bed and further protect against scour and potential scour and erosion. Plus, they also elevate the steel plate above the stream bed to facilitate future inspections. Armtec can supply, when requested, the unfactored footing loads to the consultant to assist with this foundation design. Another road reconstruction project in this slide necessitated the replacement of an undersized culvert with a 5-meter span multi-plate arch. This design build project in Nova Scotia utilized T-shaped footings founded well below the natural stream bed, and this was further protected with rip-wrap armoring. As with the Muskoka Road previously mentioned, the side arcs of this multi-plate were furnished with STRATA-CAT polymer coating to a point above the high water level mark. A corrugated arch 8-meter span was selected for this new road construction project near Bloodvein, Manitoba. A new all-weather road is currently being constructed along the east side of Lake Winnipeg, where access for most communities is currently by winter road or airplane. The map attached on the right side you see here indicates variability of soils and its ability to neutralize natural acids of surface flow water. The red area, which is where this crossing is located, indicates a very high potential for low pH and soft water conditions and dictates the need for enhanced coating protection for the steel plates. STRATA-CAT polymer coating addressed this issue, which provided a minimum 75-year design life required by the stakeholders of this new road. Where adequate right-of-way clearance is available, consideration can be given to extending the bridge culvert to suit the slope of the roadway embankment. This was the case at Reed Creek in northern Saskatchewan, where an 8-meter span deep corrugated arch was installed. Structured length for this crossing, 43 meters. Of course, one of the other advantages is that there's no bridge rail or approach guardrail required. Clear sight lines, and you don't even know you're traveling over a bridge. The arch, in most cases, with a natural stream bed, also addresses any concerns for fish passage in the stream. Now, off to La Belle Province. This challenging site utilizes a multi-plate horizontal ellipse, and this full periphery plate structure was selected by the consultants mainly due to the relatively soft and low soil capacity foundation in the area. The horizontal ellipse spans almost 7.5 meters, and in this case was supplied with a 33-degree skew cut end, and of course STRATA-CAT polymer coated plates. Horizontal ellipses are popular shapes and are utilized here in this irrigation canal crossing in Saskatchewan, where hydraulics are crucial to the performance. Even with the polymer coated plates, this structure provided an economical alternative to the more traditional precast or cast in place structures. Here are a couple of examples of steel arches selected to provide local road access under a busy 4-lane highway in Newfoundland, the Trans-Canada Highway. Determination of the required clearance requirements is crucial in selecting the most appropriate shape. Armtec can certainly assist with the shape selection once this information is determined with the stakeholder. Clearance requirements for this 2-lane roadway was accommodated in an 11.6 meter span arch. 1.5 to 1 step beveled ends reinforced with a concrete collar complete the end treatment. Corrugated round shapes are utilized for a couple of applications shown here for railway crossings. At Hardisty, Alberta, this round 6.6 meter bridge plate is used as a small vehicular underpass for access at this new railway terminal facility. In Labrador, these twin 9-meter round bridge plates on the right were constructed in 2009 to enable railway traffic to cross over the Ironstone River. An 8-millimeter thick bridge plate shell, complete with a densely compacted critical zone, supports the E90 railway live load. A precast MSC retaining wall completes the end treatment here, along with a cast-in-place wall, which is located between the culverts. Now let's move over to Saskatchewan. Here, in 2010, a section of the Trans-Canada Highway washed out following heavy rains in the southwest corner. This created a very long detour for traffic traveling this section of the Trans-Canada Highway. Armtec's local technical representative, Jim McGeary, worked very closely with Saskatchewan Highways consultants in developing a solution, in this case, to quickly repair the washout and get the traffic back flowing on the Trans-Canada Highway. The structure selected was an 11.7 meter span deep corrugated arch and it was constructed on a cast-in-place full raft footing. Additionally, the crossing was stage constructed, and this is very easily accommodated with segmental plate or bridge plate structures. And this was done over 2 seasons and completed in 2011. Here's another challenging site faced by designers in the Thunder Bay area. The existing bridge and alignment had to accommodate an intersection located adjacent to the crossing. A 12-meter span bridge plate box culvert was selected by the bridge consultant, and as you can see from the top right photo, the sight lines and safety were significantly improved. The bottom photo shows the completed structure. Off to Calgary here quickly, in 2014, an expansion of the Sheppard landfill site within the city of Calgary required an extension of a stormwater management system to control and treat stormwater runoff before it entered the natural stream course. Armtec worked with the project's consultants in Calgary to assist with shape selection, among other things, and a 6.1 meter span bridge plate box culvert was constructed to cross the storm channel. I wanted to spend a couple of minutes now just quickly introduce another corrugated plate product, liner plate. Liner plate is a segmental plate. However, it has a small variation. The plates are assembled from inside of the structure. This makes it very ideal for relining and other applications, especially relining aged and deteriorated culverts and drainage structures. Liner plate can be supplied in various finishes, as you see in these photographs, and hot dipped galvanized, polymer coated, as well as aluminum. This case study shown here and photos show the rehabilitation of an aged rail bridge and rock abutment using liner plate. One of the distinct advantages of using the strong liner plate profiles is its ability to provide custom shapes. And in this case, it was able to maximize the opening size hydraulically while providing adequate room for concrete grout, which was pumped from the ends into pre-installed, and also into pre-installed grout ports that were installed in the liner plate plates themselves. Polymer-coated plates were utilized here, as you can see, as the crossing was in a tidal area near the Atlantic Ocean in Cape Breton. Here, just wanted to utilize or show you more custom shapes that are shown here in reline applications, just to show you the variability of the various customizable solutions for these types of relines. Next, aluminum box culverts provide yet another option for bridge replacements. Lightweight and quick installation are features of this product. This small box culvert is manufactured from marine-grade aluminum and is supplied with the optional fully corrugated invert, which was selected for scour protection in this crossing. This product is typically used in coastal applications, which is the case here. In this photograph, you can see some blue water up in the top left, which is the Atlantic Ocean in Newfoundland. And then a photo of the completed installation with a cast-in-place head wall, as well as some gabion baskets used in the end treatment. Back to Alberta here for this installation. The challenges faced by the County of Wetaskiwin bridge engineers on this project was to select a low-profile replacement structure where the crossing was situated on a curved and super elevated section of the road. Several options were proposed for this crossing, including multiple barrel corrugated steel pipes. County engineers selected a single opening 10.7 meter span aluminum box and specified the optional fully corrugated invert plates for scour protection. As well, a full head wall and wing wall package was selected. The new structure here accommodated the super elevated roadway and was installed on a densely compacted gravel pad which served as the foundation. Before turning the presentation over to Lauren, I would like to quickly talk about end treatments for hydraulic structures. Bridge culvert end treatments designed to suit the site are essential and crucial to long-term performance, and they address the sometimes significant forces encountered at the inlet and outlet of these stream crossings: hydraulic uplift, piping, and erosion. Attached are a few examples here. Of course, there are many others out there. End treatments mitigate hydraulic forces, and these are considered to be the #1 threat to bridge culvert crossings. And in addition, they can provide a much more hydraulically efficient entrance to the crossing. Okay, at this time, I'd like to turn the presentation over to Lauren for his portion, but of course, I'll hang around to answer any questions if there are any.
Thank you, Ron, and good morning and afternoon to everybody. Today I will highlight some different projects, mostly from BC because I'm more familiar with them, but we have them all across Canada. I believe you can see my screen now. And the first one I want to talk about is the PENNASK Creek in Kelowna. The BC Ministry of Transportation and Infrastructure had a situation where you can see by the picture a very large fill. The existing culvert was failing, and it was a pipe arch culvert. And basically we rehabilitated it with a 2046 millimeter and a 1538 rise, so it just fit inside to minimize the grout and to maintain the capacity of the culvert itself. As you can see, it was 97 meters in length. In this section as well, we used 4 millimeter crown plates and 6 millimeter bottom plates. And of course, it was a STRATA-CAT polymer coated product was chosen for the, just trying to change the panel. The challenges was that we needed to restore the structural capacity of the culvert, given that it was a 30-meter surcharge. They did do the backfill years ago with the acidic drain rock, and so the actual corrosion that you see on the picture on the right was from the outside in. But even given that, it was amazing that the structural integrity is still in place given the amount of corrosion that was there. So the culvert was not going to fail catastrophically at this point until they chose to use the STRATA-CAT coating to provide the 75-year service life that they were looking for. And this structure goes underneath a major highway in BC. It's the Okanagan Connector. So any other options to close traffic and cut and cover it just wasn't an option. So slip lining of this structure was the best choice. And on the right, you can see how they finished the end treatment with grout and provided a structural capability once again. The next case I want to talk about is, again, for the Ministry of Transportation and Infrastructure and also Ministry of Force. And that was the Dick Booth crossing near Port Hardy on northern Vancouver Island. There was an existing 2-meter corrugated pipe in place, and they had a major rainfall event. 300 millimeters of rain fell in a 24-hour period. So BC Ministry of Transportation and Infrastructure quickly installed a temporary single-lane bridge to reopen the road because that was the only link to the small community of Holbert. They needed to maintain the essential services. So there was some construction constraints given that you needed to maintain traffic. They weren't allowed to have more than 20-minute road closures. And also on this site, given the hydraulics that was going through, engineer of record on-site engineering, they paid special attention to the water infiltration through the embankments, particularly on this site with the close proximity to the bedrock, which meant they had to take extra precautions to prevent subsurface erosion. And so that's why you see in the picture on the right-hand side, they included a cast and plate concrete cut-off wall that was anchored into the bedrock. And the intent of the cut-off wall was to ensure the water will take the path of least resistance, and which is obviously through our multi-plate structure. And also of note on the end treatments, we're using walk and load retaining wall panels that's manufactured in our Surrey plant, and also the geotextile in the background there was a temporary wall to help facilitate the temporary road crossing as well. It was a very nice project. The final size of the multi-plate was a 4.9 meter diameter by 25 meters long, and again, STRATA-CAT coating was chosen. So on this project, as you can see, it was kind of like we supplied the multi-plates, we also supplied the lock and load retaining wall, the DRS basket and geotextile, and finished it off with some W-beam guardrail. And all these products had to be shipped to the remote location, so freight was a lot of savings on freight as we stacked up our multi-products on this particular project. The other one I'd like to highlight is a nice Parkdale Creek, and it's from the West Hill subdivision in Langford. And in this case, while we like to see square ends on our structures, at times you have to go to a skewed end. And so in order to accommodate the skewed ends, you need to reinforce the ends with a reinforced concrete collar. And in this case, they were up against the property line issues, and which necessitated the skewed end. The structure was a 12-meter span, by just about a 6-meter rise and 36 meters long. And it's a lease program, so the West Hills project, in particular Parkdale Creek, very environmentally sensitive. There's a fish-bearing stream, and it meanders through. So they're basically joining two parts of their subdivision together. And they really wanted to make sure that the final project would blend into the natural landscape, and so they chose a tube-type wall, which then naturally vegetated, and is on the right-hand side. You can see the final finished product, and very nicely done, very green appearance to it. Also, on the side of another case study, which is in Thompson's Creek near Houston, in days that they had put in a couple of 900 millimeter CSPs, and I guess for a culvert salesman, this is great, because if one culvert doesn't do it, you put in another one. But as the water flows pass through and you get the scouring on the outlet, then what you end up with is some perch culverts. And the solution at this point, as you can see on the bottom, was a 7-meter span by 24-meter long open bottom arch. And the end result of that was to restore some fish habitat of over 5 kilometers of spawning and rearing habitat on Thompson Main Stream, and a further estimated 2 kilometers on 4 smaller tributaries located upstream of the Yellowhead Highway and Highway 16. So just by picking the right design change, it certainly has a positive impact on the environment, and I think it's a great success story. And that project obviously was back from 2004. And speaking of more road alignments, in this particular case, another remote site that we like to kind of highlight, the use of bin wall again. It was on a bit of a skew, so to help balance the load on the end, they used bin wall. Again, it's a remote site, and so the advantage of using multi-plate or bridge plate, it's shipped flat, and also with bin wall, you can ship a lot of square meters of wall face that will be able to be assembled on site. And also they needed to be outside the wetted perimeter of the creek. Again, a fish-bearing stream that everybody is taking into consideration. And by the pictures above, you can see how well the bin wall fitted in. And then they did use a cast-in-place concrete collar to finish it off on the end for the end treatment. It was a 15-meter span, 7.4 rise, single radius arch, and 5 millimeters thick throughout. And then design, McElhaney Engineering designed the concrete footing in the head wall. And we used bin walls of the A, B, and C design, which is primarily the depth of the bin wall. And as you have the lower on the right, you don't need as far back into the fill, and near the structure, you need the larger sizes. This one I chose to highlight because it kind of really illustrates the strength of bridge plate and what kind of loads that it's capable of carrying. This is for Tech Highland Valley Copper. And we had several contractors on site as well that we worked with. Newport Structures built the actual bridge plate, and TLC Stoneworks did the facing around the structure. It was a winter construction on a 24/7 schedule, and this is really to help avoid the frozen backfill. But they did face some temperatures low when they were building the walls, up to -25. So again, as long as your backfill isn't frozen, you can do a lot of things. But the bridge plate had two radiuses. The design parameters were span again of 15 and the rise of 6.7. And that plate was 8 millimeter in thickness. And the minimum cover is 3 meters with a maximum cover of 9.1. And you can see in the bottom left picture that they're adding the bridge plate sticker plates to the crown. And the mine haul trucks over it, so you had designed for 1.4 million pound loaded Cat 797 that would use the structure. And so the advantage really is a structurally efficient design, capable of carrying very large lag loads. So just an excellent product. You can see in the bottom right picture again how they finished it off with the lock and load panels, and those panels are cut on site to match the curvature of the bridge plate to tidy it off. So in closing as well, I just kind of restate some of the stuff that we have talked about. We customized shapes to fit the application, whether it be pipe arch or 2 radius arches or single radius or low profile. It's a very cost efficient, low life cycle cost, but really economically shipped to remote locations, as you can see on the picture that they're nested and stacked on a pallet. And if we can get them into, well, we do put them into containers, so we ship internationally to any parts of the world. But primarily, they're very ease of installation without large cranes. So primarily, if you have standard backhoes or large track hook, you can build the shapes, and we just move the plates that way. There is less design construction time is required. We do have the standard shapes, and then we review them to match your project site. And we can really design for a wide range of loading conditions, whether they be deep buried, heavy loads such as the haul trucks or track vehicles. But we typically have a reserve capacity for any overload conditions. And of course, being a flexible structure, it stands up well to seismic forces. Also, you know, if you choose the structural steel plate products, you really eliminate the bridge decks and the icy deck problems that normally associated with it. Eliminates maintenance of bridge approaches, particularly on gravel roads where you have that transition between the bridge apron and the gravel road. They always seem to need attention. Permit the use of the constant roadway section in the vicinity of the structure. I know on the coast here that's usually the product of choice because their loaded log trucks or industrial trucks don't have to slow down to navigate a bridge deck, and usually when you're going over a constant roadway, they can maintain their speed, particularly if they have to pull a grade coming up out of the ravine for out of the creek. So it does make a difference that way. And usually with road extension as well, if you work with a lot of municipalities, when traffic increases, what can we do? Well, we can match the shape and bolt on new plates and easily extend the structure as need be. The other thing as well is if you have a lot of traffic, you can build half of your structure and then divert the traffic over the new portion and then dig up the rest of the old portion and just bolt on, and away you go to complete the entire structure. So it's a very cost-effective product, and as you can see on the right-hand side, it's a nice low-profile arch that was done in the Capital Regional District, and obviously it's a West Coast picture because it's got some decent flows coming out of it. So in summary, when you're considering your crossing design, obviously you need to look at the sizing. You know, you need to look at the clearance, whether it's for pedestrian, if it's vehicular, and also obviously the hydraulics if it's a stream crossing. Durability, we can answer a lot of questions on durability, but also the Corrugated Pipe Institute, the CSPI.ca, has an excellent guide there to choose the right coating for your particular area. And we talked a little bit about alignment and culvert location. If it has to be on the skew, you don't really want to change the stream or natural stream thing. We can build multi-plate with a bent back in there as well to match the original alignment of the stream. And as Ron mentioned, end treatments are so important to control piping and scour at the inlet outlets. And as you can see, it was a lot of these things that I presented. The environmental impact mitigation, which is so important these days, can be achieved with a lot of our products, particularly with the open bottom arches, to make it a better place for all of us. And so, in closing on my portion, and we'll open up for questions, there's our contact information, or just go to our website, armtec.com, and you can find your local area rep as well. So thanks.
Ron and Lauren, thank you for your presentation today. And thank you everyone for joining today's webinar. We hope you enjoyed the presentation and found the information valuable. Our question and answer period is coming. Please submit your questions for our question and answer period while I review a couple of housekeeping items. For more information on what you've heard today, please contact a local sales representative by locating them on our website, or feel free to contact one of today's speakers at the email addresses on your screen right now. We have an exciting webinar series planned for 2015, and our next webinar will take place on June 5th on the topic Innovative Engineering Solutions. We hope you can join us. Up-to-date information and registration links can always be found on our website, so please keep checking our news and webinar section for future postings. Please stay connected with us. You can follow us on social media, on Facebook, LinkedIn, and you can view past webinars on YouTube. You can also get the latest on Armtec by following us on our newly revamped website, armtec.com. We really do value your feedback. At the end of the webinar, there'll be a quick exit survey. We'd like to know what you think of this event. One thing to note, question 6 will ask you if you're interested in receiving more invitations for Armtec webinar events. Due to strict Canadian anti-spam legislation, we're required to have your consent to receive future invitations. So please, please, please choose yes. We want to make sure that you're on our invitation list. We certainly don't want to miss out on your participation. So please choose yes. If you do choose no, you will have to be permanently removed. So we really do hope you join us. Thanks again for joining today. We'll now go into questions and answers, which will be moderated by James. So over to you, James.
Thanks, Janine. Thanks again to our speakers. Some great case examples, and they obviously stimulated a few questions here. There's quite a few that have come in, and some really good ones. What options are there for waterproofing these structures?
Yes, that's a good question, and I actually had at one point here, I was going to put a few slides in about some options for it, but just due to time constraints, I removed it. But that's a good question. Firstly, for stream crossings, typically waterproofing is not specified typically, but for pedestrian and vehicular underpasses, yes, this is a necessity. And we have a seam sealant standard, which is a tape that can be applied at the time of the structure assembly. It adds a little bit more time to the assembly process, but provides a very water-resistant structure for crossings where it's required. Additionally, we've seen impervious liners also specified. These liners essentially are installed once the structure has its initial covering of backfill. The liner is installed and essentially directs any drainage or water coming through the fill out to the sides of the structure where it can be collected in perhaps a perforated system, perforated drainage system, and daylighted out to the sides of the structure. So yeah, that's probably the two most common ways of addressing waterproofing.
Is field curving of these plates possible? And I guess this is related to multi-plate. Is there a minimum radius?
Field curving, generally no, not recommended. I mean, we have the ability to manufacture all kinds of various fittings, elbows or deflections, be it horizontal or vertical fittings. So that's obviously has to be known ahead of time, so it can be incorporated into the design. But generally not recommended, although we have seen contractors use some, be quite aggressive and robust with the structures. Not necessarily recommended, but it has resulted in some curves, but again, not recommended.
What thicknesses are available?
Yeah, for multi-plate and bridge plate, thicknesses are available. Well, for multi-plate, I'll start off. Thicknesses are available from 3 millimeter through to 8 millimeter in 1 millimeter increments, and bridge plates available in 4 millimeter to 8 millimeter in 1 millimeter increments.
What is the Manning's end for bridge plate?
Yes, good question. We don't often get a question like that because most bridge plates are arch structures with natural stream beds. So you would use a Manning's end more suitable for that type of an environment. We do obviously manufacture full periphery structures. That's a question I have to look a little bit further to and get back to Joseph on.
What type of grouting is best suited to solve piping under and around haunches of CSP culvert?
Yes, quite often we do see grouting used in those applications where there's some tightly curved radius and difficult to get into areas for backfilling. Essentially, a CLSM or low strength grout is all that's required, essentially the same strength as what would simulate compacted granular material is all that's required. A 30 MPa concrete grout is typically not required, but we have seen that happen in some cases, but typically not required. A strength that would simulate the same strength as compacted, densely compacted granular material is all that's required. Typically in about the, 3 to 5 MPa range.
Lauren, what is the cost of polymer coating compared to typical galvanized coating?
Yeah, you're probably looking at probably about another 30 to 40% more than the galvanized. So the cost is going to be offset by the longer service life. That's a given.
This is an interesting one. Are there any maps that we can use for planning purposes that show where different soil acidity would be to help?
Yeah, there's an excellent map on the Corrugated Steel Pipe Institute's website, cspi.ca, and there's a color-coded map, and highly recommend that they go and check out that. And there's a lot of excellent tools there to check out the pH ranges and et cetera, so they can make the best choice possible for their areas.
Yeah, if I might add to the guideline that I talked about in my portion of the presentation, certainly provides steps in the coating selection process, and of course if you can attain on-site soil and water chemistry parameters, that would go a long way in additionally in selecting the best coating for the application.
I'll also mention that our sales reps have been trained on water testing and have the tools to help you in the selection process in regards to the water around and the soil conditions around your site.
Do you provide assistance in structural design / hydraulic design and construction as well as supplying the plates? Yeah,
I'll maybe tackle that one. Armtec does, assist with structural design. Both products, multi-plate, bridge plate, can be designed via the equations in Section 7 of the Canadian Bridge Design Code. But recognizing that Armtec has that expertise, yes, we can assist or even do the design, the structural design of the shell of the structure. We do not do hydraulic designs. When we also do a drawing for the design of the structure, we also supply installation drawings, which are very well detailed on how the structure is to be backfilled, providing specifications for the type of backfill and the placement compaction levels that are required for the various structures required.
What is the most common method of dewatering you've seen in the past for culvert construction / rehabilitation?
One of the most common is to have a dam and bypass through either HDPE pipe or have a certain piping to bypass it through. If it's really sensitive, they'll run it through a sand filter first, so they'll make sure they're not having any turbidity in the water downstream, and then run on the bigger projects. Have you anything to add to that?
Yeah, what I've seen in some of the larger projects is diverting the water around the site as far as possible to not conflict with any of the construction activities, but measures such as lining the channel with a geosynthetic, a geotextile to reduce any silt or any turbidity in the water that's flowing through the diversion is most common. We've also seen in some cases, once the structure has been installed up to a certain level and backfilled, that the detour then goes directly through the structure until the backfill and installation is complete.
Have any of the ARCH products presented today been installed with differing footing or foundation elevations from one side of the span to the other?
Good question. I have not heard of any installations where we've had that challenge from one side to the other. Normally the installations are at the same elevation from one side to the other. So that doesn't mean we haven't done it. It's just that I may not have been exposed to an installation like that. But it is definitely non-standard.
Oh, there's a follow-up on the dewatering question. In your opinion, would it be detrimental to attempt to reline a culvert in 2 to 3 feet of flowing water?
Yes. I'd say you should take steps to, as much as possible, eliminate water during that process, also for safety considerations. Relines, especially on the prairies, in the Canadian environment are typically done during the winter when there's no flows. These are really good times to do those types of projects.
The other issue too is that you need to have a dewater to have the grout properly installed.
Yeah, good point, Lauren. Thanks.
What kind of cover soil would be preferable for absorbing kinetic energy?
Yeah, typically with structures there is a minimum requirement for the critical zone granular envelope, and that not only extends horizontally on the sides but also extends vertically above the crown of the pipe to some level. And normally this is defined by the shape and span of the structure. So this envelope is part of the design, overall design of the installation. So typically the more cover you have over a structure, the more it has the ability to absorb impact loads or even the effects of heavy live load traffic. So more cover definitely is recommended in those installations or applications.
Thanks all, and look forward to seeing you next month.
Thank you all for joining, and we look forward to hearing from you and talking to you again next month. Thank you.
Thank you, everyone.